Have you ever stared up at the night sky and wondered, what's out there at the very end of it all? What if the universe had an edge? What would you find if you could travel to it? It's a question that has captivated thinkers for centuries, and today, we're going to dive deep into what modern science has to say about it. The answer involves mind-bending concepts from topology and Einstein's theory of relativity, so buckle up. First, let's talk about how our universe began. The prevailing theory is the Big Bang. About 13.8 billion years ago, everything we know, all the matter and energy in the universe, was compressed into an incredibly hot, dense point. Then, it exploded. But this wasn't an explosion in the way we normally think of it, like a bomb going off in an empty room. This was an explosion of space itself. The universe wasn't expanding into anything. Space itself was expanding. To help visualize this, imagine a balloon. Draw a few dots on its surface. As you inflate the balloon, the dots move farther apart from each other. From the perspective of any single dot, all the other dots are moving away. The surface of the balloon is like our three-dimensional space. The key takeaway here is that there's no center to this expansion, and there's no edge on the surface of the balloon to travel to. The universe is expanding in the same way. Every galaxy is, on average, moving away from every other galaxy because the fabric of spacetime between them is being stretched. This means there isn't a physical boundary, a cosmic wall at the edge of space that you could bump into. The edge of the universe isn't a place, it's a time, the Big Bang itself. But let's say, for the sake of argument, you decided to try anyway. You hop in the fastest spaceship imaginable and head out in one direction. Would you ever get to an edge? Well, you'd immediately run into a couple of major roadblocks. The first is the speed of light. According to Einstein's theory of special relativity, nothing with mass can travel at or faster than the speed of light. It's the ultimate cosmic speed limit, so your journey would be incredibly long. But there's an even bigger problem. The expansion of the universe is accelerating. This was a shocking discovery. Scientists thought the gravity of all the matter in the universe would be slowing the expansion down. But instead, it's speeding up, driven by a mysterious force we call dark energy. This means that distant galaxies are receding from us at incredible speeds. In fact, beyond a certain distance, known as the cosmic event horizon, galaxies are moving away from us faster than the speed of light. Now, you might think this violates Einstein's theory, but it doesn't. The galaxies themselves aren't moving through space that fast. It's the space between us and them that's expanding so rapidly. The consequence is that the light from those galaxies will never reach us, and we will never be able to reach them, no matter how fast we travel. They are effectively cut off from us forever. So, even if there were an edge to get to, you couldn't reach it because space is expanding faster than you could ever hope to travel through it. This brings us to another fascinating question. What is the actual shape of the universe? This is a field of study called cosmology, specifically dealing with the universe's topology. There are three main possibilities for the overall geometry of the universe. It could be flat, like a sheet of paper. In a flat universe, if you travel in a straight line, you'd keep going forever. This kind of universe is infinite. Or, the universe could have a positive curvature, like the surface of a sphere. If our universe is shaped like a four-dimensional sphere, or a hypersphere, it would be finite, but it would have no edge. Think back to the balloon analogy. If you're an ant walking on the surface of a balloon, you can walk forever and you'll never fall off an edge. If you walk in a straight line long enough, you'll eventually end up right back where you started. If our universe has this shape, you could theoretically fly your spaceship in one direction and eventually return to Earth from the opposite direction. It would be a finite, but unbounded, universe. The third possibility is a negative curvature, which is often described as being shaped like a saddle or a Pringle chip. This type of universe is also infinite and unbounded. Based on our best measurements of the cosmic microwave background radiation, the leftover heat from the Big Bang, the universe appears to be very, very close to flat. This suggests it might be infinite. However, our measurements have a margin of error, and it's also possible that the universe is just so mind-bogglingly vast that the part we can see looks flat, just like a small patch of the Earth's surface looks flat to us. The true shape is still one of the biggest open questions in cosmology. Now, you might have heard the term observable universe. It is important to understand the distinction between the observable universe and the entire universe. The observable universe is the part of the cosmos that we can see from Earth. It's a spherical region centered on us, and its boundary is defined by the distance light has been able to travel to us since the Big Bang. This boundary is called the particle horizon. It's about 46.5 billion light-years away in any direction. This doesn't mean the universe is 93 billion light-years across and then just stops. It just means that's the limit of what we can currently detect. The light from anything beyond that horizon simply hasn't had enough time to reach us yet. So, what lies beyond the observable universe? This is where we move from established science into the realm of theoretical physics and speculation. If the universe is truly infinite, then beyond our horizon is simply more universe, more stars, more galaxies, more clusters, stretching on forever. It's a staggering thought. In an infinite universe, every possible configuration of particles would have to repeat itself somewhere. That means that out there, somewhere beyond what we can see, there could be another you living a slightly different life. In fact, there would be an infinite number of yous. But there are other, even wilder theories. One popular idea is the multiverse. In this model, our universe is just one bubble in a vast, frothing sea of other bubble universes. Each of these universes could have been born from its own Big Bang and might have completely different physical laws and constants. Some might be sterile and empty, others might be teeming with forms of life we can't even imagine. Another idea comes from string theory, which suggests the existence of extra dimensions beyond the three spatial dimensions and one time dimension we experience. Our entire universe might be a brain, like a membrane, floating in a higher dimensional space, possibly alongside other brain universes. So, to come back to our original question, can you travel to the edge of the universe? The answer is almost certainly no. If the universe is infinite, there's no edge to travel to. If it's finite and unbounded, like a hypersphere, you would just end up back where you started. And in either case, the accelerating expansion of space puts the most distant parts of the cosmos forever beyond our reach. But even though we can't physically journey to a cosmic edge, the question itself is incredibly valuable. It pushes us to explore the fundamental nature of reality, to grapple with concepts of infinity, and to confront the limits of our knowledge. It reveals a cosmos far stranger and more wonderful than our ancestors could have ever dreamed of. We may be confined to our small corner of the observable universe, but our minds are free to wander the vast expanse of what might be. The universe may not have an edge, but the quest to understand it is a journey without end. Thanks for watching. If you enjoyed this cosmic journey, be sure to like, subscribe, and hit that notification bell for more explorations into the mysteries of our universe.